The date's 3/11/12.
3/11/12.
13.
13.
Let's go back a year.
No. Alright, so this is 7-2. These are relations and functions. And really it's just an extension of what we started talking about yesterday.
Yesterday was Sunday.
Or Friday. One. Alright, so just as a quick review, this was one of the example problems that we did last Friday. We talked about that magazines cost $4 per magazine, and we filled out this function table.
Yeah, that's simple.
Okay? So I just want to remind us with input, we talked about that input is the x variable. This is a new thing, though, that I'd like you to add. It's independent variable. So your input or your x is your independent variable. And that's because when you're input, you can choose those values, and it doesn't depend on the output. All of them. I would write why this is the independent variable, yes. You already have down that it's the x. That's in your notes from last week, Friday. But the new part of this is that it's your independent variable. And that's because really we can choose whatever values we want for the input. And it's the output that's going to affect, the output is going to be affected by the input. So therefore your output is your dependent variable, because that changes depending on what you put in for the input.
So this is what you're on the internet now.
I am. The World Wide Web. People get jobs off this. Alright, so if we go back to this example.
Hey,
I'm sorry.
Brandon. No.
Okay, this right here is your independent variable. Because we could decide to put whatever number of magazines that we want to put in there. We could put in 12.
12. Oh, yeah.
I mean, we could put in 20. We could put in 30. Because the input then goes into the rule, and then the output is affected by whatever the input is. So in other words, the cost is dependent on how many magazines that you buy. Okay? And I think that you talk about independent and dependent in science class too, right?
Yes. Yes.
Yeah.
I think so. I'm pretty sure that you did. Huh? No. Okay, we ready to move on? So this is just another slide that reminds you that your x is your independent, your y is your dependent, your x is your input, your y is your output. And we can put those input and outputs into an ordered pair. So that's why I have it written here as an ordered pair, because now, in coming up in our next section, we're going to take these function tables, our inputs and outputs, and we're going to start graphing these functions. So our x is our independent, y is the dependent, and we can put it in as an ordered pair. Right, Drew? Okay, so just another reminder too from yesterday. You don't have to write this down. I just want to remind you that a function is a relation that has exactly one output for every input. That definition should already be in your notes from Friday. A function is a relation that has one output for every single input. So, if I look over here at these ordered pairs, I want to know if this relation is a function, and then we need to explain why or why not. So let me see if I can just make this a little bigger for you.
Whoa. It's a little bit too big.
All right, is it too big?
Oh.
Well, it helps maybe a little bit. So we've got an ordered pair of 2, 1. We've got 4, 3, 5, 4, and then 9, 7? Yes,
Yeah.
9, 7, although it's not there. So 2, 1, 4, 3, 5, 4, and 9, 7. So to be a function, it says that there needs to be exactly one output for every input. And it might be kind of hard to see the inputs and outputs when they're in ordered pair form like this. So we could put them into a table or just get them organized this way. So the input is 2, the output is 1. The input is 4, the output is 3. Input is 5, output is 4. Input is 9, output is 7. So is this a function? Is there exactly one output for every input?
Yes.
Yes. So is it a function?
Yeah.
Yes. Yes, it is a function because there is one output for every input. In other words, there is exactly one y value for every x value. True?
I don't know the rule on that one.
Huh?
I don't know the rule.
You don't know what the rule is on this one?
Yeah.
This isn't exactly a function table. It's just a way to organize your ordered pairs. Okay. So let's look at this. Is this a function? And if we think about how we had it organized on the previous slide, perhaps we should get it organized that way. So our input is 2, our output is 1. Our input is 5, our output is
4.
our input is 9, output is
7.
our input is 2, our output is 3. Now, is this a function? Is there exactly one output
No.
for every input?
Yeah.
Raise your hand if you say no. Raise your hand if you say yes. Raise your hand if you didn't raise your hand. Okay, those of you that said yes, why did you say yes?
Because
each of them have
one.
1.
So there's one. So for every input, there's only one output.
Yeah. Yeah.
Okay, what about those of you that said no? Devin, you said no right away. Why did you say no?
Because for 2, you can have 1 or 3.
Okay, so 2, although it's listed here twice, 2 can either go to 1 or 2 can go to 3.
Me neither.
So is this a function?
No.
No, because there are 2 outputs for the input of 2. Or if you look at it that way, 2 can go to 1 or it can be 2 to 3. So there are 2 values for y with the 1 value of x. So therefore, no, it is not a function. Another way to see if a relation is a function when we have a graph is to do the vertical line test. So when it's a graph, and we want to check on a graph if it is a function, we can do the vertical line test. Okay, and here's what the vertical line test says. If you take a vertical line, or a pencil, right, that's a vertical line, and you move it, as long as there is not more than 1 point on your vertical line, it's a function. So is this a function?
Yeah.
Was there ever a point that's on the same vertical line?
Oh, no.
No, so this is a function. For each x value, there is exactly one y value. Sure. And really, I mean, you could just write vertical line. Ooh, okay. You could just write vertical line test. That's what this is. So if you use your pencil and do the vertical line test, there should only be 1 point on each of your vertical lines, which tells you that for each value of x, there'd only be 1 value of y.
Wait, only 1 point for each y? Oh, okay, now.
Okay, so let's name these ordered pairs. What do we have?
1.
What's this?
0.
0,
0, 3.
0, 3. What do we have here?
0, 1. 2, 1. 1, 1. 1, 1.
1, 1.
Yeah.
What's right here?
3, 6. 2, 4.
2, 4. Oh, we got 1, 2, 3, 4.
3. 4, 2. 4, 2.
4, 2. Oh, here's the origin. If that's confusing some of you.
Oh.
That might be affecting what some of us are saying. Okay, so this one was 1, 2, 3, 4, 2. And then we've got
6, 6.
5, 5.
1, 2, 3, 4, 5.
7, 2. Not good.
And then we've got
7, 2.
7, 2. Okay, so for each value of x, is there 1 value of y?
Yeah. It is
Yes.
a function.
So it is a function. So we can check it this way by just looking at the ordered pairs, or we can check with our vertical line test. There was never a time where there was more than 1 point on the line. Okay? So if we looked at this one, is this a function?
No. Why not?
Because there's 2 dots on that one line.
Yeah.
Okay, let's look. There's 1 dot here. I wish. There's 2 dots there, right? So because there was 2 dots here, that means that we have 1 value of x but 2 values of y. What are our 2 ordered pairs? Remember, this is 0, 0. What's this?
3, 2.
3, 2. And
3, 7.
1, 2, 3.
7.
Good, 3, 7. So we have the 1 input of 3 going to 2 and going to 7. So therefore, this is not a function. Okay? Are you with me so far?
Yeah.
All right, the last thing we're going to talk about today is something called function notation. And function notation is a way to write a function as an equation. So we may have an equation, y equals fx, or y equals 4 times x. In function notation, we would write this same equation as f of x equals 4x. And I just want you guys to just chill a second and let's work through this before you geek out. And we read that then as f of x. So as an equation we have y equals 4x. Y equals 4 times x. 4 times x. In function notation we'd have f of x equals 4 times x. And this is telling us then, whatever we're going to put in for x, like if we have f of 3, that means wherever we see an x, we're going to put in a 3. So in that equation there, in function notation, f of 3 would equal 4 times 3. So f of 3 would equal 12.
So x always equals 3?
No, x equals whatever we're putting in for it. It means that we're solving this function in terms of whatever we put in for x. So here we're solving the function if x is 3. If x is 3, it would be 12. But if we're solving this function, let's say we want to find f of 5. So that means instead of putting in 3 for x, like we did when it was f of 3, now we put in a 5 for x. So it would be 4 times 5.
Is it always 4 for x?
It is in this equation because that's what our function is right now. But your functions are going to change. You know, like the equations are going to change. Okay, what would f of 10 be? In that same, using this, right?
40.
F of 10 would equal 40. Okay, so it's just another way of writing it.
Oh, this is going to be easy because all you're doing is timing what you put in for x times
super easy.
4.
Times whatever it is. And what's your input? Like if we're looking at this one, what is your input?
F. 10.
What is your input?
4. X.
X. So your input would be 10. Your output would be
4.
in this one, your input is 3. Your output is
12.
12. Okay? So what about this? If we want to find f of 3, if f of x equals 5x.
Oh, I got it.
So find f of 3 if f of x equals 5x. So that means we want to solve this function
Oh, that's easy.
when x is 3. Shannon, what do you get? 15.
Oh.
So we substitute in f of x equals 5x. If it's f of 3, wherever we see an x, we're going to put in 3. So f of 3 equals 15.
Simple.
What about this? Find f of 2
Ooh.
if f of x equals 3x plus 1.
Oh, I got this. Oh, this is hard.
So we want f of 2 equals 3x plus 1.
That would be. Oh, this is easy.
Yeah, totally.
So anywhere that we see an x, what are we going to put in? A 2. So f of 2 equals 3 times 2.
Plus 1. That would be.
So what does f of 2 equal, Tyler? F of 2 equals 7.
Yeah, so yeah.
Remember, order of operations tells us to multiply and then add. All right, that's our homework. Page 384, which I will hand out to you. You can stop.